Okay, folks, this lesson is just a continuation of the last lesson. So we're going to continue to practice finding the average value of functions, and then also we're going to get a couple of reps with some less common function types and their integral and derivatives rules. So we're going to do some rational functions and some trig functions. Okay, this first example, that's a rational function. It's a ratio of two things. Ratio just means division, right? And we're going to use this derivatives rule quite a bit in this lesson. So the derivative of the natural log of x equals 1 over x. So this function is a version of this particular derivative that we get here. So that's going to help us find the antiderivative here when we integrate. Notice here, it wants us to express our answer as a constant times the natural log of 3. You're like, what in the world does that mean? I'll show you here in a second. Essentially, we want to simplify whatever we get. Let's set it up. To start, think about how to set this up. You should know from the previous lesson. You should have said 6 minus 3 on the bottom, and then the integral from 3 to 6 of my rational function here, dx. Okay, so that's exactly the same as the previous lesson. Now, what I'm going to do here is I'm going to condense this. So I'm going to turn that into a 3 on the bottom. That's not rocket science, right? And then I'm going to factor out this 12. So this is really 12 times 1 over all of this, and the 12 I can pull out. Okay, and that's just going to make my life a little bit easier. Make sure you follow what I did there. Now, there's a couple different ways I can approach this. So I know that my antiderivative of this is going to be the natural log of whatever's on the bottom here. So natural log, and we'll put that in absolute value when we take these, because natural log can only take positive inside of it, only take positive values. And then notice now, if I took the derivative of this, I would get 1 over 2x minus 3 by my derivative rule here. And then chain rule, I would multiply times this 2. Okay? And we want it to just be a plain old 1. So I'm going to throw in a 1/2 here. And then I can check, and you can check, that this, the derivative of this now, well, here, I'll even show it, would be, oops. So if I took this derivative, I would get 1 over 2x minus 3 times 1/2, and then chain rule times the derivative of the inside, which is just 2, right? And then those cancel out, and then I'm left with what I had there, okay? You could also have gotten the same result by using a u substitution with u equal to the bottom of the fraction here. So you can try that if you didn't like this method. I still have my 12 over 3 in front. 12 over 3 is just 4 though. And I'm evaluating from 3 to 6. Okay. I'll simplify that a little bit more. So 2 times the natural log of 2x minus 3 from 3 to 6. And here is where we start to get concerned about how we simplify it. So I'm going to evaluate with my bounds. So I'm going to plug in my first bound. 2, I'll write it first, 2 times 6 minus 3 minus 2 times the natural log of 2 times 3 minus 3. Okay, so I've plugged in my bounds. I'm subtracting the upper bound from the lower bound, just like we always do. We'll simplify. So 2 times the natural log of 12 minus 3 is 9, minus 2 times the natural log of 6 minus 3 is 3. Okay. Now we need to start to remember our logarithms rules. I'm just going to factor out that 2 first. So I have the natural log of 9 minus the natural log of 3. Okay, so hopefully you remember this from pre-calculus. When I subtract two logs, let me make this a little clearer here. When I subtract two logs, I can combine them and then divide them. So this becomes 2 natural log of 9 over 3, and then 2 natural log of 3. So that should seem familiar from early in your math career, but that's what it means when it says to express your answer as a constant times natural log of 3. So you just type in that 2. I think it even makes you write natural log of 3, so all you type in is 2 in this particular case. Okay. So really we're practicing 3 different things altogether here. We're practicing setting up this average rate of change, we're practicing finding this integral, and then we're practicing simplifying these logs a little bit. All 3 of these things are going to be useful to you on your AP exam. So we'll continue with our second example, which is a dreaded trigonometric function. Just f of x is cosine of pi times x. And we have some dreaded fractions as my bounds here. And we want the average value. Okay? And it won't, just to note, it won't always ask you for the average value in this particular lesson. It's a mix. So sometimes it will just ask you for a plain old integral. So make sure this part, you only include this part if it asks you for the average value. If it just asks you for the plain old integral, you obviously do not need this. So here's our setup. Did upper bound minus lower bound on the outside, and then the integral from 1/6 to 11/6 cosine pi x dx. And then we'll simplify that sum on the outside to start. So I'll get 1 over 10/6. I just subtracted the top of my fractions. 1/6, 11/6 are still my bounds. Now, again, I could use a u substitution here. I could let u be pi x. But I could also just note that the original function, if this is a derivative, the original function must be sine pi over x. And if you weren't sure on that, you could have looked at your derivatives reference, right? And then if I took this derivative, chain rule would be multiplying by pi over x. So I want to do the opposite, which is 1 over pi. I'm going to bring my outside down. So this is my integral. I'm evaluating from 1/6 to 11/6. And I'm going to bring my outside down. So 1 divided by a fraction flips it. So 6 over 10. And then, let's see, let's simplify this a little bit more. So 6 over 10 is just 3/5. So up front I get 3/5 pi on the bottom, because pi is on the bottom up here, right? And then sine pi of x. And then I'm plugging in these 2 things. So here I would go to my unit circle. Okay? And like, actually, you would need your unit circle in this case because it wants a simplified fraction. On the AP exam, you could use your calculator in radians mode and give a decimal too. But here I'll go to my unit circle and I look for 11 pi over 6 and 1 pi over 6. And 11 pi over 6 is coterminal with 5 pi over 6, right? So I look for 5 pi over 6 and pi over 6. I get 1/2 both times. So as I plug this in to evaluate, 3 pi, 3 over 5 pi, I'm going to factor that out or leave it factored out, and I'm going to do, you get negative 1/2 minus 1/2 is what we get. Negative 1/2 minus 1/2 is just negative 1. So we get 3, which is just negative 3/5 pi. So that is the average value of a trig function. Remember, the integrals rules come from your derivatives reference, and these So when I evaluated, we're using the unit circle there.